All right, folks, I had a right brain fart there because I went completely. I got distracted. I'm not gonna lie, got distracted by my visitor. Started thinking about what was that, and lost my mind on this. Another good excuse, another good reason to study by yourself. So, A is equal to V minus U divided by T can also be written as A is equal to delta V divided by T. I'm trying to find the change in velocity, the increase in velocity. So all I have to do is A times T equals delta V. Reading 12 times 4 is equal to delta V. Now, it's the exact same thing. You get your answer. 48 meters per second is the change in velocity. But it's just a nicer way of doing it rather than doing 1, 2, 3, 4. The mass of the airplane, an airplane, is equal to 750 kilograms. Calculate the change in gravitational potential. I'm so sick of gravitational potential energy equations. As it descends from 1,300 meters to the ground, gravitational field strength is 10 newtons per kilogram. But we're doing this together, you and I. We're on a quest to become as good as we possibly can. At maths, we are on a quest to make sure that we do not drop any marks. Like Don Quixote and his ass. Is it donkey? I might have been an ass, actually. I'm not entirely sure. Pop that into my calculator. 750 times 10 times 1,300 is equal to 9,700,000. Oh, wow. We actually had that number earlier on. Funny. The speed of light is 3.0 times 10 to the 8 meters per second. Velocity of light is 3.0 times 10 to the power of 8 meters per second. The wavelength, Sheep Daddy, is 5.8 times 10 to the minus 7 meters. Calculate the frequency of yellow light in Hertz. It's lighting it up to me. What I want to do, velocity is equal to frequency times wavelength. I'm going to divide across by wavelength so that I've got my frequency, my wavelength, which is Sheep Daddy. Sorry, I was getting way ahead of myself there. The frequency, 3.0 times 10 to the 8 divided by 5.8 times 10 to the minus 7. This is simple as pi if we are only using our calculator correctly. So I'm going to press AB 3.0 times 10 to the power of 8, and then I'm going to press down. I'm going to write 5.8 times 10 to the y to the x minus 7, giving me the answer of 5.17. 5.17 times 10 to the 14, and the unit I'm using there is Hertz. I tell a joke about frequency. I tell it so often, and you'll laugh so much that it hurts. Ha 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 ha. Andrew skis down a hill again. Andrew is one for the skiing, isn't he? He loves himself a bit of skiing. His mass is 67 kilograms, so his momentum is about 2,000 kilogram meters per second when his velocity is 31 meters per second. 31 meters per second. Momentum is equal to mass times volume. Momentum is equal to 67 times 31. Momentum is equal to 67 times 31. 2,077 kilogram meters per second. He falls over when his momentum is 2,000 kilograms. Oh no! After he falls over, he slows down by sliding across the snow. It takes 2.3 seconds for his momentum to reduce to 0. Calculate the average force on Andrew as he slows down. Now for this, we're going to have to use a little used equation. So let's calculate. Let's gather up my momentum. Momentum before is equal to 2,000 kilogram meters per second. An object that isn't moving, has got 0 kilogram meters per second. The time taken for that change in momentum is 2.3 seconds. We're asking to find the force in newtons. The equation that we need to use is F is equal to mv minus mu divided by t. This comes from F is equal to A times m, but instead of A, I'm going to write V minus u divided by t, giving me F is equal to V minus u times m divided by t, giving me overall F is equal to mv minus mu divided by t. The change in momentum divided by the time taken is equal to the amount of force required. So F is equal to 2,000, take away 0, divided by 2.3, 2,000. That says 20,000 divided by 2.3 is equal to 869.56. F is equal to 869.56 newtons. I'm going to give that up as 870 newtons. Actually, I'm not. I'm going to do 869.6 because it's one decimal place there, so I'll give it a decimal place back. Alrighty then. Figure 9 is a diagram showing a rocket that is sent to space to try and change the path of a small asteroid. Oh, wow. The rocket has got a mass of 5.5 times 10 to the 5 kilograms. It is traveling to the right at 14 kilometers per second. That's fast. Which of these is the correct calculation of the momentum of the rocket in kilogram meters per second? So let's have a look then. This is the equation for momentum, which is fabby-dozy. Mass is equal to 5.5 times 10 to the 5 kilograms. And it is traveling at a velocity of 14 kilometers per second. I'm going to have to multiply that by 10 to the 3 because it's kilometers per second, and I want it in meters per second. Momentum is equal to, I do not know how many kilogram meters per second. I'm going to multiply, I don't know why I'm doing it left to right here. P is equal to m times v. V is equal to, I think it's because I wanted more space, but that was just very, very silly. Mass is 5.5 times 10 to the 5 multiplied by 14 times 10 to the power of 3. Put that in here, 5.5 times 10 to the power of 5 multiplied by 14 times 10 to the power of 3. And I have got this great big number. So I would scribble this down, 7700, comma, 000, comma, 000. Let's count them across. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got 7.7 times 10 to the power of 9. And that is an answer that is given to me here. So my answer is C. Now, if you accidentally give A, don't panic, don't cross it out. Draw a line through it and give the one that's true. The asteroid has got a momentum is equal to 7.5 times 10 to the 10 kilogram meters per second, and a mass of 8.0 times 10 to the 6 kilograms. Calculate the velocity of the asteroid, the speed of the asteroid, and I don't know how many meters per second. Momentum is equal to mass times velocity. Momentum is equal to 7.5 times 10 to the 10 multiplied by 8.0 times 10 to the, I can't read that, 6. Pop that into my calculator. Oh, stupid. What mistake did I make here? Can you tell that I'm getting tired of doing these questions? And I tell you what, that's what's going to get me. That's what's going to make me fail. Because it wants me to find the velocity. Momentum divided by mass is equal to velocity. So actually what I want to do is 7.5 times 10 to the 10 divided by 8.0 times 10 to the 6. I must remember that mistake as well and let everybody know about it. Pop it into my calculator. 7.5 times 10 to the power of 10. Down. 9.375 times 10 to the 3 meters per second. Okay, wake up, McKelvey. Come on. Student investigates how the average speed of the trolley varies with starting height. Figure 9 shows the trolley and runway. There's your starting height. There's your velocity in meters per second. Just in case you don't know, meters per second is the same as meters to the second to the -1. They all mean the same thing. Oh, stop shouting at me. There we go. Let's have a look at what question they're asking us. Oh, we've got a graph. Nice. The trolley has got a mass of 650 grams. Mass is equal to 650 grams. Calculate the average kinetic energy of the trolley, which had a starting height of 0.075 meters. Okay, I'm not going to do this. I'm not going to go straight into my mathematics because it's asking me to find kinetic energy. EK is equal to I don't know how many joules. And the equation I need is EK is equal to 1/2 times mass times velocity squared. So it's asking me for the amount of kinetic energy. We had a starting height of 0.75 meters. Sorry, like I said, writing this with a mouse is hard. 0.075 meters. So I'm going to look here, 0.05, 0.01. Halfway in between that is 0.075. I don't really know I'm going to do this properly. No, that way. Over, across. Yeah, that one, still that one there. Okay. And then going over here, I need to find out the speed at that particular height. Now, I think I did that quite well. It's in between. Is it? Oh, I can't really tell. 0.61, I think that's about 0.61. 0.61, 0.62. I'm going to say that the velocity of this was 0.62 2 meters per second. Now, you get a bit of wiggle room, you'll get plus or minus 1 or 2, so that's fine. Why am I doing this? Because it's giving me a starting height and a graph. It's giving me a speed on the y-axis. I need to find out which number corresponds, and that was almost perfect, corresponds with the starting height of 0.075 meters. And then I just pop it into my equation. EK is equal to 1/2 times, oh, nearly forgot, I need to times this by 10 to the minus 3, which is the same thing as dividing by 1,000. 0.65 times 0.62 squared. Pop it into my calculator. 0.5 times 0.65 times 0.62 squared. Wow, meaning the average kinetic energy is EK is equal to 0.12493, or I can say 0.12 joules. Electricity can be generated using a water turbine. Water gains kinetic energy by falling from the top of a dam. Calculate, what did the fish say when he swam into a wall dam? Ha ha ha. Calculate the minimum heights in I do not know how many meters that the mass is 7.0 kilograms of water must fall to gain a kinetic energy EK 1,300 joules. Well, remember, if something has got 1,300 joules of kinetic energy at the bottom of a fall, it must have had 1,300 joules of GPE at the start of a fall. So I can also write down that the potential energy it had was 1,300 joules. I'm looking for the height, so I need to use my equation. EP is equal to m times g times delta h, the change in height I'm looking for, so I shall divide across by m and g. EP over m times g is equal to delta h. EP is 1,300 over 7 times 10, because g is equal to 10 newtons per kilogram. And that is my change in height. I'll put my numbers into my calculator. A over b, then 1,300, and then down, 7 times 10. Giving me an answer of 18.5714. 18.5714, or I can do 18.57 meters. No significant figures, no anything like that, so I can just crack on. Oh, I hope it's not kinetic energy. Please not kinetic energy. I hate kinetic energy. I'm fed up of kinetic energy. Oh, it isn't. As water enters the turbine at the bottom of the dam, the kinetic energy EK is equal to, no, pardon me, the EK of 8 kilograms of water. The mass is equal to 8.0 kilograms of water, and the kinetic energy of that is 1,100 joules. 1,100 joules. Calculate the speed of the moving water as it moves along. Velocity, as I do not know how many meters per second. EK is equal to 1/2 times mass times velocity squared. V is equal to the square root of EK over 1/2 times mass. V, which is equal to the square root of EK, which is 1,100 over 1/2 times 8. Pop that into my calculator. Again, I'm very sorry about my handwriting. It's just, I'm writing with a mouse. 1,100. Maybe I should have done this under a visual. I should have done this under a visualizer. I should have done this under a visualizer. I should have done this under a visualizer. Speed is 16.58 meters per second, and everybody's happy there. Pilot begins to land an aircraft. The aircraft lands with its wheels on the runway as shown. Well, good. The aircraft is moving forwards. The velocity of the aircraft when it lands is 75 meters per second. The mass of the aircraft is 130,000 kilograms. Calculate the momentum of the aircraft. Momentum is equal to, I do not know how many kilograms, meters per second. Momentum is equal to mass times velocity. Momentum is equal to 130,000 kilograms multiplied by 75 meters. My momentum is equal to 130,000 times 75. I swear to God, you lot better be watching this. They love this number. Where is this number coming from? Have I just done the same question over and over? The aircraft comes to a stop. State the momentum change of the aircraft when it lands to when it stops. An object is moving, has got a velocity of 0 meters per second squared. So momentum being mass times velocity, anything multiplied by 0 will equal 0. Momentum equals 0. So the change is the difference from that to that. We've already done this question, haven't we? Two students try to determine a value for g, the acceleration due to gravity. They must measure the time, t, for a small steel ball to fall through a height, h, from rest. They measure t to be 0.74 seconds. Using a stopwatch, they measure h to be 2.50 using a meter ruler. Calculate the value for g. is equal to, I do not know how many newtons per kilogram, but they're giving me our equation there, so all I have to do is substitute it, is equal to 2 multiplied by 2.5 divided by 0.74 squared, popping that into my calculator, A over B. 2 times 2.5, yes, it does seem like you should just be able to write down 5, but you're showing all your working out, you're double checking 0.74 squared on the bottom, giving me an answer of 9.13 meters per second squared. I swear to goodness. Goodness gracious me. Righty. Let's have a look. I think we've got like just another 5 or so pages left. Sorry, folks. It's not that I'm bored with you. I'm thoroughly bored with being by myself in this room, and I don't enjoy it. But I'm going to keep on going because I want to be useful to you. They record the time t for 2 more drops from the same height. The 3 values for time t are that. Calculate the average time t to an appropriate number of significant figures. So the equation for the average is equal to the sum of the numbers over the amount of numbers. But again, you don't need to know that. So I should do 0.74 plus 0.69 plus 0.81. Are any of those anomalous? Oh, damn it. Blah, 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 blah. Stop it, stop it, stop it.